Hello again, welcome back. This is the Mastercam course. We're gonna talk about how can we calculate our feed rate and the spindle speed. And spindle speed and the feed rate is calculated by cutting speed and feed rate per teeth parameters. Cutting speed is quite important parameters. This is the meter divided by the mean, and we can easily see that values in our tool catalogs. Actually, according to my tool and workpiece materials, that values is calculated with experiment actually. And according to that perspective, we can decide our cutting speed. For example, we can see 200 and 300. For example, we can select any values in that and in those values. So according to my perspective, if you use and the optimum cutting speed, so it means that you can get and better surface roughness and less tool wear, and you can also decrease your cutting time. So you can also see the some presentation here. This is the actually how can we calculate the spindle speed. You can see here, and this is my cutting speed values here, meter divided by the mean and tool diameter, and then we can easily calculate according to that formula. But in Mastercam, we don't need to focus on and that's kind of formula. Actually, we just need to turn to here to organize our cutting speed. Of course, we also need to think about how can we and which tool diameter we should use in our and the milling operation actually. For example, we can use the 20 millimeter tool or 10 millimeter tool. Okay, that's also quite important question we should ask and we should ask. So okay, that's it, and this is my cutting speed parameters, and according to that part we can easily calculate our spindle speed. Our spindle speed unit is and actually rev divided by the mean. Okay, so after that we're gonna see feed rate per teeth. So this is actually quite and similar with the turning operation. In the turning operation we only have one insert in our and the machine, and after that this values and actually is calculated like this, and the one rev and 0.15 millimeter we're gonna move. So this is our feed rate per teeth parameter. So according to that perspective, so we can also see here like this one actually, this is my actually feed rate per teeth parameters. So yeah, this is the turning operation. It's easy, but when we turn to the milling operation actually, we need to know how many and the fluid we have in our tool. So to handle that stuff, I just need to hit the next button, and then we're gonna see the number of the fluids number here. So we have the 4 fluids in our tool. So it means that we have the 4 insert our tools. So we need to multiply that values with 4 and then spindle speed, and after that we're gonna get our feed rate. So feed rate is quite important parameters. We need to be careful about our feed rate. If you use optimum feed rate, it means that you can optimize your cutting time and also your surface roughness and also your tool wear. So that's why, and that two parameters is quite important. So when we focus on the plunge rate, so when we are entering our materials and the workpiece, so it means that we're gonna see the huge cutting force. So it means that we need to use and the less plunge rate. So this is my feed rate, and after that I just need to write my feed and the plunge feed rate like this. Most of the time we prefer to use half of our feed rate as a plunge rate. So this is also quite important. And after that I can also say that feed rate is also calculated by and the different perspective. For example, according to your toolpath geometry, if you have the sharp corner in your toolpath geometry, it means that you cannot use the higher feed rate. Okay, so another perspective about your chip thickness, and if you have the high chip thickness, it means that you're gonna use the less feed rate. If you use actually low chip thickness, it means that you're gonna use the high feed rate. So it is also possible to calculate your feed rate according to your chip thickness. That's also another perspective to calculate your feed rate. So, but that is the static feed rate we can calculate according to all operations and according to our actually toolpad geometry or chip thickness. We can change our feed rate here. This is another optimization perspective. So yeah, that's it. That part is quite important. You need to optimize your feed rate and spindle speed. So yeah, you need to be careful about that stuff. Let me turn to the here as a final. So you can see that this is my feed rate per teeth values, millimeter divided by the teeth with rev actually. And then this is my cutting edge, flute, number of flute in our tool. And then we can calculate our feed rate like this one. So that's it. So this is the main perspective in our process. Okay, so that's it. Yeah, this is the Mastercam perspective. You just focus on your tool catalogs and then decided your cutting speed and your feed rate per teeth values, and then feed rate and the spindle speed is going to calculate it. Of course, you need to be careful about your tool diameter. Okay, tool diameter is also quite important parameters. Okay, so that's it. Thank you very much. If you have any question and how can I handle and your feed rate and spindle speed, please don't hesitate to ask me, and please write your comments on the blog. Thank you very much.